Hi, if you're new to this channel, I'm Mr. E.
Swipe up, subscribe. Alright,
To what?
so subscribe to my channel, duh.
Channel.
Don't worry about it. I don't want you to subscribe. They know what's up.
Or do they?
Yeah, they're 2% smarter than what they're working with.
Wait, what?
71, thank you.
Well, you're still 29 away, so
Yeah, well, we'll see about that.
you'll never get there.
Alright, so, growth and decay. First of all, exponential decay function. This isn't on your paper, but just look at them. Just looking at them, what do you think might be a decay? Looking where the variables are.
Going down.
Well, yeah, obviously, Cole, but which of these would near that? If you put that on your graph.
B.
C. Wait, no. Oh, no.
Miss Wick, why do you say D? Say it.
The second number isn't a full number.
Ooh.
You're really close. You're right. We're looking at that second number. Well, what's different about it than the other ones?
It's small.
Less than 1.
It's less than 1, which means if I'm multiplying things, right, I have an exponent here. If I have an exponential where it's less than 1 in there, that means I'm going down, I'm decaying. Now, is that helpful for you?
Yes.
I mean, probably, because if you're doing an exponential decay problem now, and you have something that's bigger than 1 in there, you should realize that's going to be wrong. Right? It should be going down. So, we're just a little pre-lesson question there. First and foremost, so we're talking about exponential growth, an exponential growth model. Right? Exponential growth on a graph looks like that. Right? It grows exponentially. It grows bigger and quicker and quicker. So, first and foremost, y equals a times 1 plus r to the t power. What all that means, y is obviously your desired outcome, like where you want it to end. A is your initial amount. What did you begin with? If we're talking about putting money in a bank and seeing how much it grows, A is our initial amount that we put in there. R is our growth rate. Now we're going to use decimals, because if you put percents in, it's going to get really big really fast. So we're using decimals when we put our rate in there, and then t is our time period. So like if it's over 5 years, 5 would be t. If it's over 12 years, 12 would be t. Alright? So that's our 3 parts to our equation there. Now, when we're doing problems, I would highly advise you write out A equals, R equals, T equals. That way you know what you're plugging into your formula. Do you have to do that?
No.
No, but I'm going to, and I would advise you to as well. So, first example, we're talking about depositing $500 in an account that pays 8% annual interest. What is the balance after 6 years? So first of all, what's my initial amount? How much am I putting in there? 500. So A equals 500.
Let's go.
My rate.
8%.
Guys, all the extra talking. Shh.
Oh.
Our rate, Cole, is what?
0.08.
0.08. Do not put 0.8. That'd be really bad because that means 80%.
That'd be kind of
Right? 8 and 80 are totally different things. And then my time period.
6 years.
We're lasting 6 years. Okay, so go ahead and plug those in.
Billy lives 6 years.
Y equals 500 times 1 plus 0.08 to the 6th power.
I'll put it.
Well, it's the same as 500 times 1.08 to the 6th power. We should be able to plug that right into our calculators. Oops, we'll talk about that later.
Ooh, that's a big
500 times 1.08 to the 6th. You can plug it all right in. You get 793.4371615. Now, it didn't tell us what to round to.
I got it.
Why the hundredths?
Money.
It's money, right? We're talking about cents. So $793.44.
Woohoo.
Good. Any questions on that?
That was pretty
Should we
good.
try some more examples?
That was very difficult.
Yep, we're going to.
For sure.
Savings certificate of $1,000 pays 6.5% annual interest. What is the balance of certificate when it matures in 5 years?
That's a good question.
Well, my A value, I'm starting with $1,000. My R, my rate, is 0.065. Right, we're writing our rate as a decimal always. And my time period is 5 years. So we get Y equals 1,000 times 1 plus 0.065 to the 5th power, right? We're using our formula. So go ahead and punch in your calculator. 1,000 times 1.065 to the 5th. Punch in your calculator. Is that what you got?
Yeah.
How much money should that certificate be worth in 5 years? What's that, Jared?
1,370
And what?
9 cents.
And 9 cents.
Good job, Jared.
Good. Very good. Awesome. The second part now to this question asks, if you want to know when you'll have $6,000 on your savings certificate, what could you do?
Multiply.
Well, we're not
Divide.
going to multiply. Just think about it though. What's our initial amount going to be still? 1,000. What's our rate going to be still? 0.065. What's my time period going to be?
Don't know.
Why?
Don't know. So it's going to be X. Right? Or any variable you want it to be really. I really don't care.
390.
So if I plug all that in, y equals, 1,000 times 1.065 to the x power. Hey, what do I want y to end up being? 6,000. So I can plug that in too. Now, does that help if I plug 6,000 in here?
You gotta solve for.
You gotta solve for x. Hey, quick question before you start solving for x and get stuck. Do we know how to solve for a variable that's an exponent?
Yeah.
No.
No.
At this current juncture in time, we do not.
Are you sure?
I'm positive.
29.
Now, we will learn, I want to say next unit even, we'll learn how to do that. So for right now, what we're going to do is we're going to use our calculators to help us solve a problem like this.
Thank you, big fella.
What's going to happen is we're going to have y equals 1,000 times 1.065 to the x, and we're also going to have y equals 6,000, because that's what we want it to equal. Now what we're going to do is we're going to take and look at our calculator, go right into our calculator, and we're going to go to the y equals button. Top left, and we're going to plug those two formulas in. 1,000 times 1.065 to the x. Hey, does everyone know where the variable button on the calculator is?
Yeah.
It's right next to alpha. It's got x, t, theta, n on it.
How'd you type it in there?
Where?
Right next to alpha. So go ahead and put those in.
How'd you put that in there?
Because I'm very fast school.
I don't like this.
Let me know when we all get there.
We hit enter.
He's good.
Enter.
Fellas, you're all good? Yeah, put it.
Shake your head no.
X is right next to alpha. It's got a variable button. X, t, theta, n.
Theta.
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 What's that?
Like when you do sine, cosine, tangent. Talking about angles.
That was last year, wasn't it?
We're going to talk about that this year too, don't worry.
We
Yep, we're
That
going
was
to do
not
more
a-
things with it.
That
Hey,
was not fun.
yo, we good?
Yes.
Do I have those in?
Yeah.
Okay, what you're going to do is you're going to graph. And should,
No, I don't see it.
I don't see it.
oh no. Why do you think it doesn't show up on yours? What?
You gotta do second and graph and it'll show you the.
No, we don't want to look at the table.
But my graph's not. I don't see
Why don't you see it on your graph? What do you
it.
think?
The graph's too small.
It's too small,
Oh.
right? You're going from negative 10 to 10 on both the x and the y axis probably.
How do you change it?
You need to adjust what we call your window.
Oh, yeah.
Oh,
So you're going to
yeah.
hit window. You can copy mine if you like. I went from 0 to 100 because x values are talking about years. So if it takes more than 100 years, I don't care for it.
Delete, delete.
And then we're talking about y value is our money. Well, we said we wanted to go up to how much money? We want to know when we got to how much in the problem. What do we say we needed to get to? 6,000. So I went to 8,000 because I know I had to get past 6,000. All right? So go ahead and copy mine down. And if you hit graph, you should graph then.
Graph. Ooh, that's a big. Blah, blah, blah.
Oh, I know.
I see it now.
Okay.
It's a blue line. Oh, there's a red line now. I don't like that.
Okay, did we all get it to graph?
Yep.
Yes, everyone?
Oh,
Do you get graph? Now, hey, where do you think we're going to look at?
Right at the red line, where they intersect.
Where they intersect, right? The red line is 6,000 always. The blue line
no.
is that formula we created, and we want to know when does it hit the red line. So we want to know when does it intersect. Now you can trace like that, like I see a lot of you doing, but that won't give you the exact thing.
I just did.
What you can do is you can go to hit second, trace. If you notice, there's one that says intersect on it.
Whoa.
So if you hit 5, you're going to need to hit enter 1, 2, 3 times because it's asking for your 2 curves and it's asking you to guess. And then it should give you
What?
your answer. So I'd probably write that down if I was you.
Wait, what?
Second trace, and then intersect,
I'm confused.
and enter 3 times. Second trace, the 5th one down is intersect, then enter 3 times. And it should tell you, well, when y is 6,000, so it's $6,000, it's going to take us approximately 28 and a half years to get there.
Got a different answer.
Did we all get that on our calculators?
We'll try it again.
Okay.
So is that the answer?
That is our answer. That takes us 28 and a half years to get there. Because we round it to nearest 10.
Oh, I only had to hit it once. Wait.
Okay? Like I said, next unit when we do logarithms,
Well, now we know how to do it, so.
then we'll be able to do it by hand and actually learn it that way.
Oh, alright, I got it now. 3 times.
Okay.
Wait, was this correct?
Okay.
Was this correct?
Yeah. All right. Any questions on that? Okay. We just did that. All right. Let's try another problem. Another growth problem. Shh. We're talking about 20 bunny rabbits. Release into the wildlife. Population triples every 5 years.
Hey, that's good.
2 questions we need to answer. First, what is the percent increase each year? Second, what is the population after 5 years?
Ooh.
Can we answer one of those already?
Yes.
Which one?
The first one.
No population after 5 years.
Why can we answer the population after 5 years?
It tells you
We
it
have all
triples
the
every-
answers.
We have everything we need to find an answer, right?
Oh, it's 100.
It says we start with 20 rabbits. It triples every 5 years.
60 rabbits.
So it should be 60 rabbits after 5 years, right?
That's it?
If we triple 20,
That doesn't seem right.
okay.
They only grow 40 days.
All right. Well, let's take a look. Let's try and find the growth rate, the percent increase. I know my initial amount is 20. My rate, or my R is what I'm looking for, so I'm going to leave it as a variable R. Right, if you want to use X, you can. Not a big deal. My time, we said was 5 years. Right, so if I write it out, Y equals 20 times 1 plus R to the 5th power. Oh, I have 2 variables in there. Does suck. Can't solve it right now.
No, you can't.
Why can't I?
You said can't.
I know. Why can't I? I know I can solve this. I'm missing some valuable information we just found out.
It triples every 5
It triples. So what should Y be?
3.
60.
Oh.
Right? If in 5 years, come in, Sim.
I don't know why I said 2.
If it triples, it should equal 60. Right? If we took 5 years to get to 60, it should be good. How are we going to solve for R? Just solve.
Calculator.
Right? Let's start by dividing by 20. I get 3 equals 1 plus R to the 5th power. Well, how do I get rid of that 5th power? Don't say the square root. That'd be getting rid of a square. The 5th root. If we take the fifth root of both sides, I take the fifth root of both sides, it gets rid of that fifth power. Now, you could put the fifth root of 3 in your calculator right now, but I would wait. That's just me. So I don't want to round. So I'm just going to write the fifth root of 3 equals 1 plus r. What's the last thing I'm going to have to do?
Add.
1.
Subtract 1. So in your calculator you can put the fifth root of 3 minus 1. Go ahead and do that. In your calculator, the fifth root of 3. Enter. Minus 1. Enter. And that should give you your R value, your rate. So, front and back. Is there anything you got wrong on the front or the back? Okay? Right, tomorrow. Okay? Alright.
2.2%.
Did anyone do it?
2.2%.
That does not sound right. Hey, when you did this in your calculator, shh, hold on. What did you get? 0. What?
2, 4, 5, 7.
2, 4,
Oh,
what?
I did plus 1.
5, 7.
Yeah, 5, 7.
3, 0.
Dot, right? Hey, if we've been talking about rates this whole time, have they been giving us decimals?
No.
So should we answer in a decimal?
Yes.
No. So I need to change to percent. I'm going to round to, let's say, the 10th place. 1 more decimal 2 spots, I should get 24.6%. So please write it as a percent, right? They've been giving us all rates as a percent. You should write any answer you're looking for a rate as a percent as well. Okay. Because it doesn't tell us what to round to, I would take 25. Okay? On the test, it should tell you what to round to. Okay? Alright. One more thing we're going to do. Okay, we've talked about growth rate this whole time. We're going to do decay rate. The formula is almost identical except we're subtracting our rate instead of adding it. Which would make sense, right? If it's going to go down, if it's going to decay, we're going to subtract it. So A is still our initial amount, R is our rate, or our decay rate, and T is still our time periods, except now instead of 1 plus R, it's 1 minus R. So y equals 8 times 1 minus R, all to the T power.
We're supposed to do the problem.
We will do it in a second, once people write it down. Alright, so we bought a used car for $18,000. The value of the car will be less each year due to depreciation. It depreciates. The car depreciates at a rate of 12% per year. Find the value of the car in 8 years. Well,
What should it even mean?
my initial amount is $18,000. Right?
Money.
My rate, it is losing value at 12% per year, so 0.12. And my time period is over 8 years. So I don't know what my car is worth after 8 years. So y equals 18,000 times 1 minus 0.12 to the 8th power. You could put it in your calculator like that, or you could do 1 minus 0.12, which would be 18,000 times 0.88 to the 8th. Right? Same thing, I just did a subtraction. So go ahead and punch in your calculator, figure out how much is your car worth after 8 years.
That's not that good.
6,000.
Hold on, let people get a chance to do it.
I got it.
Hold on, Cole.
Never seen a car have sense.
What do we get? Cole.
6,473.42.
$6,473.42. Your car lost $11,000 worth of value.
That's horrible.
Alright, is that it? Is that what we got?
Is that like a typical
Any questions? All right.